Hello everyone, this is week 2 now, and I hope everything is fine. And for you guys, I guess the first week could be tough, right? So as we move on to the second week, and I hope you kind of figure out how you're going to do this semester and where you're going to learn and what are the deadlines going to be and when will you have the final exams. So a lot of things. This semester is definitely going to be tough to you guys, and this semester is new to me as well. And I may make some mistakes, and you may make some mistakes too. That's okay. We will figure things out, and my job is to figure out the things as we move on this semester and make sure whatever weird thing or different thing or tough thing happens in this semester won't harm your learning. Okay, so be patient with me. This is a lecture 2, and we are going to talk more about Python, and we are going to learn a little bit about the keyboard input and variables. So a very quick review of the first lecture. We reviewed the course policy, and especially I want to remind you again about the exams. We have 4 midterms, so 2 written and 2 coding, right? So if you miss a midterm, your final exam score will be the substitute. And if you miss a final, we are going to have a much bigger trouble. You will receive a 0 on your final and also zeros on all your missed midterm. So try to make a reminder on your calendar and to remind you when is your final exam. And if you give me an early notice, and I might be able to give you an I. Okay, so and the due dates, I understand with multiple online courses going on, the due dates could be hard to track. So for my course, I want to make it simple enough. But the due dates will always be on Mondays, 10 a.m. Okay, so for the day exercises, they're due on 10 a.m. Monday, and also the Flipgrid videos. And later, when we have the projects, they will always due on Monday, 10 a.m. So I try to make it as consistent as possible to help you guys. Okay, and last week we talked about some cool things computer science can do, and I'm arguing that computer science is one of the best major you can do because computer science can change the world. And I gave you a little bit more information about Python and why Python is a good programming language, and we set up the computing environment together. So by now, you should have a working computer. Your computer doesn't have to be super fast, and if you have a computer which is 5 years old, no problem, or 10 years old, probably you can still run Python. Okay, and you should have Python and PyCharm, and those are 2 things we need in this course. And you should be able to do a hello world program. You just do a print and then parentheses and then code and whatever content you want to print. Okay, so here's a little more information about this course. For this course, you need 2 textbooks, and they're both online, and we are going to focus on the first textbook, How to Think Like a Computer Scientist. And for the default interpreter, and you need to configure that only once on your PyCharm, and remember we are using Python 3. If you have an old version of Python, a Python 2 installed on your machine, I highly recommend you to uninstall that. But if you have an older version of the Python 3, like Python 3.5, for example, probably you can still use that version without too much issue. Okay, and for the PyCharm, we are using PyCharm Community Edition, and that is a free version. And if you need to come to campus and you want to find a computing lab on campus, you can use the CAS 2004, or now this building is called Condon Hall. Okay, So today we are going to talk about the number systems. We are going to see different versions of the number systems, and we will focus on a little more on the binary numbers, and we are going to see variables and keyboard input, how we are going to type something and then Python can take it. Okay, the first thing, well, number system, and let's start from the decimal number. The number system we know the best, right? So for each digit, we can have from 0 to 9, a total of 10 different numbers, right? So, and then when we increase a value, say, so if we want to increase the value by 1 on this digit, what does that mean? We are increasing by 1, right? Okay, and if we increase 1 on the second digit, what does that mean? We are increasing 10. Okay, so if I change it to 1021, I'm increasing the value by 10. Okay, and how about I increase one value here on this digit, the third digit? I'm increasing 100, right? And then if I'm increasing 1 here on the fourth digit, I'm increasing 1000. Okay, so if we want to follow this rule, we know that this digit represents 1, which is 10 powers 0. This digit corresponds to 10, which is 10 powers 1. This digit corresponds to 100, so that is 10 powers 2, and then this digit corresponds to 1000, which is 10 powers 3. Okay, so this is how does our decimal number system work. Okay, if I want to break down this 1011 like this, and then by adding them all together, I got a 1011 back. Why? Because I'm breaking up a decimal number and then assemble it back into a decimal number, so it is the same value. Okay, so how about a hexadecimal? A hexadecimal is a 16-base number, right? We have the numbers from 0 to 9 and then A, B, C, D, E, F. Okay, so from 0 to 15 on just one digit. Okay, so if we use the 1011 again, if I increase this digit by 1, I'm increasing by 1. But if I'm increasing this digit by 1, I'm adding a 16, right? And if I'm increasing this value by 1, I'm adding a 16 square. And then for this digit, that is a 16 cube. Okay, so if we want to break this 1011, and then, well, remember now the base number should be 16 instead of 10. So this one corresponds to 16 power 3, and this 0 corresponds to 16 power 2, and this one corresponds to 16 power 1, and this one corresponds to 16 power 0. So if I'm taking this hexadecimal number 1011, break it, and then put it back, so I'm converting this 1011 from a hexadecimal number to a decimal number, a 10-base number, and then what are you going to get? You are going to get 4113. So I'm converting the 1011 from a hexadecimal number to a 10-base decimal number, and that is 4113. Okay, how about octal? So octal is a 8-base number. Okay, so if we are just using the similar rule, but remember now the base number will be 8 here instead of 10 or 16. So we use the same rule. We are taking the 1011 as an octal number, and then we want to cast it or force it or convert that to a 10-base number, and then we will have 521. Okay, so the next question, do you think 59 is a valid octal number? Think about it. The answer is no. Why? Because you see a 9 here? Well, for a octal number, it only for each digit, it only supports from 0 to 7, right? So 59 is not a valid octal number. And the next thing, how about that? How about binary? So 1011. It can be a binary number, right? Because a binary number supports only 0 and 1, and then we are okay because we have 10, 11. Okay, if we follow the same rule, and then we want to break the 10, 11 into a decimal number, and remember we are using the base 2 number system. So this 1 corresponds to 2 power 3. This 0 corresponds to 2 power 2, and this 1 corresponds to 2 powers 1, and this 1 corresponds to a 2 power 0. So adding them together, we got the 11. What does this mean? If we have 10, 11 as a binary number, what is the equal value in the decimal system? That is a 11, right? Okay, so just now we talked about if we are taking the 10, 11 from different number system and we want to cast that into a binary, how do we do that? Oh, sorry, if we want to cast it into a decimal, how do we do that? And then let's do a reversed project. If we have a decimal number, how do we cast that into a binary number? Okay, so well, here is how we can set up this problem. We want to set this problem by doing a sequence of divisions. So the first division will be like this. Say if we are trying to convert 156 to a binary number, and we are going to divide this value by 2. And then for this division and all the later divisions, the rule will be we write down the integer answers below, and then we are writing the remainders to the right side. Okay, so the first thing, well, 156 divided by 2, and then you will get a 78. So the 78 will be written down below, and then what's the remainder? The remainder is a 0, right? So the remainder will be on the right side, which is a 0 here, and then the integer answer should be 78, and then written down here right below the 156. And then you continue doing the division. So 78 divided by 2 again, and then the remainder is a 0, and the answer is a 39. So 39 divided by 2, so you will get 19, and then 1 as the remainder. So you keep on doing this. When do you stop? You stop when you reach a 0 here. Okay, so after you reach a 0, and then on the right side you will see a sequence of the remainders, and what you're going to do is you just take all the remainders in the reverse order. So in this case, that is 1 0 0 1 1 1 0 0. That is the binary version of the 156. So this is how you can convert a decimal number into binary. Okay, so this is what I want to show you in this lecture video, and I will continue in the next video.